There are some unique things about sheet metal parts which make them somewhat special. They will have a uniform thickness. Also, sheet metal parts typically start out as flat and then punched and formed into shape. At each bend, material must be added. That material is called bend allowance. Sheet metal can be formed using dies, brake presses, or automatic bending machines. I have a great deal of experience in sheet metal while working in the product engineering of a commercial refrigerator and freezer manufacturer. We always dimensioned our parts to the inside of the flange. We will keep this in mind as we design our sheet metal parts. Let's get started. This is the part we want to model today. Notice how the dimensions are extending from the inside of the bends. I have started a new part model using inch, pounds, and seconds units. I will start a new sketch on the front plane. Next, I will place a center point rectangle on the origin and set the length to 60 and the height to 8. Those numbers are coming from the Pan 1 configuration in the problem drawing. When working in sheet metal, it's a good idea to display the Sheet Metal Command Manager. To do this, right-click on the Command Manager tab and check the Sheet Metal Tools on. Here we want to change our rectangular sketch into a sheet metal part. We use the Base Flange tool, which will set all the important parameters about the sheet metal. For all the parts in this class, you will use bend tables. In this case, we'll use the sample steel table. Select 16 gauge from the drop-down list and leave the other settings at the default values. Now we will add the side flanges, but notice those are not straight. To accomplish this angle shape, we'll use the Edge Flange tool and pick the right edge of the part and pick again on the front side of the part to direct the flange toward us. Now pick the large Edit Flange Profile button in the Properties Manager. Remove the vertical constraint and add the appropriate dimensions. 6 across the top and 3.75 along the bottom. Make sure you're using the Add Material to Bend option. Mirror that flange to the left side using the right plane as the mirror plane. Next, we should add the 1.75 flanges across the top and bottom edges of our part. Again, we'll use the Edge Flange tool. Pick on an edge and pick again to the inside of the part to define the direction of the flange. Adjust the flange length to 1.75 and use the Add Material to Bend option in the Properties Manager. Select inside the Select Edges box and pick the remaining edges along the top and bottom of the part. All of our regular SolidWorks tools are still in play. Start a new sketch on the top surface of the bottom flange. Sketch a rectangle based on the dimensions given. Use a center line to keep this rectangle centered on the flange. Extrude your sketch and use the Link to Thickness option. Use the Edge Flange tool to add the upward flange on the rectangle we just created. Pick the edge and pick above the edge to define the flange direction. Set the flange length based on the given length. Make sure to use the Add Material to Bend option. The last real sheet metal thing is to add a hem on the top of the last flange. Use the hem tool with the closed option set to the length of 0.5 inches. All the part lacks now are the holes and slots. Use the Hole Wizard or Extrude Cut features to add those. I'll leave that for you to finish. This part is configured with 3 different sizes. Rename those changing dimensions and use a design table to drive your configurations, just like you've been doing on the previous configured parts. I do want to discuss the drawings. For every sheet metal drawing, I want you to create one sheet showing orthographic views of the finished formed part. That drawing needs to include all the dimensions and information about the material, sheet metal gauge, finish, and it must also include a note stating to remove all burrs and sharp edges. In addition to the sheet showing the form views, you must create a sheet for each flat pattern. When adding dimensions, be sure to dimension to the inside of the bins. The flat pattern drawing will use ordinate dimensions to locate the XY values of every feature, holes, slots, sizes, material information, a label indicating flat pattern, and the specific part number shown. You may want to rotate your view to put a more appropriate edge along the bottom. This part will require 4 drawing sheets. Use the Ordinate option of the Smart Dimension tool. First, define the origin point. Next, locate every point in the X direction. I'll give an angular dimension for the notch so I don't have to locate the endpoint of it. The ordinate dimensions are connected together, but you can break the alignment. This will allow you to reposition those dimensions above the part. Repeat the process for the Y dimensions, and don't forget to add your holes. And create a separate sheet for each flat pattern.